Hello everyone, I'm Shruti Sachin Jadhav from Zeal College Pune, and now I'm going to present an overview of my internship at Emertxe. Also, I'll talk about the microcontroller based washing machine simulation, which is a project that I've completed as part of my internship program. So, starting with all the things that I've learned throughout the internship. Firstly, I strengthened my knowledge about C programming and its applications, and specifically the applications in embedded systems. I gained knowledge about various data types in C language, such as integers, float, characters such as signed and unsigned characters, etc., and how and why they are used. Also, I learned about the input-output functions like printf and scanf. In C language, there are various loops such as for loop, while loop, do while loop, which are used when we need to perform or repeat certain lines of codes. Also, there are various operators used to perform certain operations in C language. Some of them are arithmetic operators like addition, subtraction, multiplication, division, and modulus operators. Assignment operators like equal to, not equal to, less than, greater than, less than equal to, greater than equal to, etc. Logical operators like or, and bitwise operators like bitwise and bitwise or, and various such operators. Then there are range errors like overflow and underflow. Basically, overflow occurs when a variable gets a value which is bigger than its maximum limit, and underflow occurs when a variable gets a value which is smaller than its minimum limit. Now, in C language, using C language, we need to perform certain tasks to solve problems. So, we use functions that perform certain tasks, and they also can be reused several times. There are built-in as well as user-defined functions. The built-in functions include printf, scanf, sizeof, etc. And also there is a special type of function which is a recursive function. The recursive function calls itself to solve a certain problem. And another concept that I learned is the macros. Macros are the preprocessors, and they are used as the shortcut names which are defined using hash define. Now coming to the DKP, it stands for drivers, kernels, and protocols. So the drivers are the modules that allow the interconnection of hardware and the application. Kernels, they are the core of any operating system, and protocols, various communication protocols between the hardware software such as the I2C protocol, SPI protocol, UART protocol, and further in this project I have used I2C protocol. Next, I also learned about the embedded systems fundamental concepts. So basically, embedded systems are the integration of hardware and software which is used to perform specific tasks. Various components of embedded systems are the hardware. The hardware might include microprocessor or a microcontroller, the memory, the input-output interfaces, and various sensors and actuators. And the software components include the firmware or the embedded C code which we write, the device drivers, and operating systems if used. So these are all the things that I learned during the internship. And now coming to the main topic, that is the project. A microcontroller based washing machine simulation using the PicsimLab software. So the objective of this project is to simulate the functioning of a washing machine using the PicsimLab software. Various tools that are used for the implementation of the project are the PicsimLab software, which is used for simulating the microcontroller, and the microcontroller used in this project is the PIC16F877A. The PicsimLab allows virtual testing of the washing machine circuits, and the second software used is the MPLAB IDE compiler. It is basically a compiler used for writing and compiling the embedded C code for the microcontroller. Now the various peripherals used are the LCD, which is used for displaying the machine status, like the status of which program is currently running and the timer countdown. Second is the switches. They are basically used for providing inputs like start, stop, cycles, or selecting certain options. Then the buzzer. It alerts the user about the completion of particular cycle or if any error occurs. Then the fan or a motor. It simulates the spin motor operation for the spinning clothes. Another one is timers, which controls duration of each washing stage, like a washing stage, the rinsing stage, and the spinning stage. And lastly, the GPIO pins, which are used to interface the LEDs, switches, and buzzes with the microcontroller. The project requirements are shown through the diagram below. The functional requirements include the power on function, stop function, navigate function, and door status function, which are provided using various switches. They are provided as the input to the microcontroller. And the washing status is displayed through the CLCD. The buzzer and motor or the fan are used for the output. So there are certain requirements which include the first requirement, which is the power on screen, which will be done using this fifth switch or switch 5. It includes the turning on of the machine. So when we press the switch 5, the machine will turn on and it will display a message of powering on washing machine. Second requirement is the washing program screen. It will use switch 4 and switch 5 for its inputs, and it will be used to display various functions in the menu like daily, heavy, delicates, whites. These are the different types of wash programs which will be displayed. And using S4 switch, we can navigate through all these options. And if we want to select a particular option, then we have to long press the S4 switch in front of the highlighted option, and that will be selected. Next requirement is the water level screen. In this, S4 switch is again used. So the various water levels that will be displayed are auto, low, medium, high, and max. So S4 switch will be helpful to navigate through the options, and if we want to select a particular option, then we need to bring the asterisk mark in front of the desired option and long press the S4 switch. So that particular option will be selected. Next is the start screen requirement. It uses switch 5 and switch 6 for the input. This is used to start or stop the selected program. So if we select switch 5, then the display and time will be the display will show time and the program used, and the function will start. But if we choose switch 6, then the screen will go back to the washing program screen. Next is the function screen, which is the main part. It uses switch 1, switch 5 and switch 6 as its input. Basically it will display which function is going on, like wash, rinse or spin, along with the time, remaining time for that function. So switch 6 will be used to stop the particular program. It will stop at whatever time and function it is, and switch 5 is used to again play the or restart the function. So it will restart from wherever it has stopped or whatever time it has stopped at. It will restart from there. And the use of switch 1 is used to indicate the door status. If we continuously click on switch 1, then the buzzer will start buzzing, which will indicate that the door is open, and the screen will display a message of door open, please close the door. And the last requirement is the completion status screen. It will basically print the program is completed and remove clothes. When all the program is completed, timer has gone till 0, then this screen will be outputted. Now I'll show the project demo. So we have used MPLAB X IDE for compiling the code. Various header files we have used, like the CLCD header file, this digital keypad header file, the main header file, timers and washing machine header file. So the washing machine header file basically contains all of the functions which are used throughout the program. Then CLCD file is used, digital keypad file, ISR, timers, washing machine functions. Here we have displayed or defined all the necessary functions that are used throughout the program. And the main C file, which is using the header main.h, and all the functions are integrated in this main file. Now I will build the program main project. So our build is successful. Now we can see it's functioning on the PicsimLab display. The board I have selected is PicGenius, and the microcontroller is PIC16 F877A. Now from the files, I will load the hex file of my program, which is the washing machine.hex file. Now we can see the press key 5 to power on the washing machine. The first message displayed, which is used to start the machine. So this is switch 1, 2, 3, 4, 5 and 6. So I will press switch 5 to start the program. We can see that the powering on washing machine screen was displayed, and it takes us to the washing program screen, where various options are included, and I can navigate to them through this switch 4. Heavy, delicates, whites, satin wash, cottons, woolens, bed sheets, rinse plus dry, dry only, wash only, across over, and it repeats itself. If I want to select delegates, I have brought my asterisk sign on delegates, and I will long press the switch 4 so that it will be selected and it will take me to the next screen. So now the water level screen is displayed. Similarly, on this screen also switch 4 we can use to navigate through all the options: high, low, medium, maximum, auto. I will choose the low, and for choosing it I will long press the switch 4. Now the start screen has popped. Here switch 5 and switch 6 are functional. So if we want to continue with the program which we have selected, then we can click on switch 5. But we want to go back and change our options, then we can click on switch 6. It will take us back to the washing program option. Again we can choose the required options. I'll choose the same again, the delicates, and water level I will choose low. And I will start the program using switch 5. Now it will display the total time required, and the function wash has started. The fan has also started, indicating the motor is started. Now the switch 6, I click the switch 6, which will pause the function. The fan has stopped, and the function which was wash going on, it has paused there, and the timing is also paused. Now if I want to resume it, then I will click on switch 5. It will resume from wherever it has stopped. It will go back. So after wash, the rinse program, and then after rinse, the spin program is displayed. And once it is done, the fan will stop rotating and the buzzer will go on. So basically this was all about the project and its simulation on PicsimLab. So we have successfully completed the simulation of the washing machine program using PIC16F877A. And PicsimLab served as an effective tool for learning and applying all the concepts that we learned in the previous lectures. Also, it has offered hands-on experience to complement the theoretical knowledge, and it provided a foundation for exploring all the features and other functions in the field of automation and control systems. So I thank all the mentors who have taught us throughout the internship. They very they have guided us very nicely, and it was a very great experience with Emertxe, and thank you so much.